Hello, everybody. I will deliver the Professor Gerard Hooft's critique of a quantum mechanics research thesis. The claim that quantum mechanics does not fully explain the physical world has once again taken center stage in the scientific community. The protagonist of this assertion is Gerard Hooft, an emeritus professor at Utrecht University in the Netherlands and 1999 Nobel laureate in physics. On the 4th, after receiving the Special Breakthrough Prize in Fundamental Physics, he delivered sharp criticism of existing physics theories and research practices in an interview with the Scientific American on the 8th. The Breakthrough Prize in the Fundamental Physics, often referred to as the Oscars of Science, recognized his extensive achievements across the entire field of physics and comes with a $3 million award. In 1999, Professor Hooft, along with his mentor uh, Martinus Veltman, received the Nobel Prize for proving the renormalization of non-abelian gauge theories, a cornerstone of particle physics. This discovery is considered a key achievement that supports the mathematical consistency of the Standard Model and laid the foundation for modern particle physics. Even more attention-grabbing than the award announcement were his remarks. He stated quantum mechanics is essentially just a statistical theory and is not sufficient to explain the fundamental laws of nature, expressing a bold perspective. He further pointed out current theories cannot explain why particles choose certain paths when they collide, arguing that our known physical laws are confined to a framework of probabilities. This perception leads to a fundamental questioning of the widely accepted concept of a quantum superposition. Using Schrodinger's cat paradox as an example, he asserted the idea that a dead cat and a living cat can exist simultaneously is not scientifically valid, dismissing the superposition concept as a mathematical fantasy rather than a physical reality. He expressed confidence that the physical world can be explained in a much simpler and deterministic way, emphasizing there must be more fundamental variables that we have not yet discovered. He also expressed skepticism about quantum computers, a prime example of quantum technology. Professor Hooft pointed out the computational results provided by quantum computers are merely stati- statistical interpretations, and their limitations are clear in problems that require definitive answers. He wondered that current quantum information science is deviating from the essence, stating true innovation will begin by shedding quantum concepts and finding more fundamental and error-free classical variables. The physics community's response to these claims is mixed. Some researchers view his perspective as provocative but worthy of consideration, while others criticize it as excessively critical. He himself expressed disappointment, saying, "My ideas are often treated as just another eccentric theory." However, he maintained his stance, emphasizing innovation comes from the courage to break away from existing perspectives. The holographic principle, which he proposed in the early 1990s, also reflects his original thinking. Through this theory, he suggested a probability, the possibility that all information in a three-dimensional space can be contained on a two-dimensional boundary surface. And this concept has since become a core element in black hole physics and quantum gravity theory. However, he expressed concern about the popular misuse or mystical distortion of this concept. Science should be as concise and clear as possible. Reason, not mysticism, should guide science, he said. In the final part of the interview, he stated, the problem we face is not the lack of new answers, but the inability to create new questions. He emphasized, in the past many people asserted this question is too difficult for humans to know, but science has always found ways to overcome those barriers. What we need now is the courage to temporarily set aside the framework of quantum mechanics and start again from the essence. His argument goes beyond simply denying existing theories. It reflects his belief in a deterministic universe and his philosophy that the language of science should be clear and predictable. Professor Hooft is presenting a new perspective to the stagnant flow of theoretical physics, hoping that the scientific community will recover more creative and daring thinking. This message serves to remind us that the true essence of science lies in the shift of thought rather than technological advancement.